Here, solve using the quadratic formula. Write this down. X equals negative b plus or minus b squared minus 4ac all over 2a. And you have to label a equals 3, b equals 1, and c equals negative 1. You're going to substitute. All right, there you go. I'm going to move this a little bit more to the left. Make sure you replace the letters with the right numbers. So negative 1 plus or minus. I like to do what's inside the radical first, right? If you have a calculator, it does it for you. 1 squared. And here, let me use my, you guys want me to use my calculator? Split view. All right. So what's going to happen here is, I'm going to zoom in. I do 1 squared. 1 squared minus 4 times 3 times negative 1. Do you guys see what I did there? Oh, sorry, syntax error. So let me see if I can do this. 1 squared. This might happen to you as well. Minus 4 times 3 times negative 1. There you go. 13. There you go. All right, so you replace, now that I got 13, inside the radical house. 13 goes there, over, and then multiply. 2 times 3 is 6. And there you go. Since 13 is not a perfect square, that's it. Your answer is just x equals negative 1 plus or minus radical 13 plus 6. It's really nice. All right, now it's number 41 says solve using any method. So any method means you can use quadratic formula, you can use factoring, you can use completing the square. I am going to look at this and see, is there a GCF I can take out? Okay, 2, negative 6, negative 20. I can take out a GCF of 2, and let's see how simplified this gets. So 2 parenthesis, and we get x squared minus 3x minus 10 equals 0. Remember, your GCF always goes in the front, right? That's where the GCF goes. Okay, now, if I look at negative 10 and I look at negative 3, I have to ask myself, can I use X method? Because obviously when I have a 3 term, a trinomial, and especially in standard form, I want to make sure if the x is even possible, okay? Let's see. Can we find 2 numbers that multiply to negative 10 and add to negative 3? All right, 1 times 10 and 5 times 2. All right, do you think the 5 and the 2 work? Let's see. Oh, one of them has to be negative. Okay, so then let's make the bigger one negative because we need an answer. When you add them, you get negative. That seems to work, right? So yes, the X method was the way to go. If the X did not work, then I would go to a quadratic formula probably. So what I'm going to do now is I'm going to use my box. Once I use my box, I am going to put those terms where they belong. X squared, top left, negative 10, bottom right. And those 2 magic numbers, right, I split up my negative 3x into negative 5x and positive 2x. There we go. I find my GCF of the top row. Oh, look at that. The GCF is nice. It's just x, and I just fill in the rest of the boxes. X times positive 2, and x times negative 5. I found my factors. So what I'm going to do is I am going to rewrite that statement up at the top and 2 is a GCF times x minus 5 times x plus 2. Don't forget, this equals 0. That means our y's equaled 0. Or y equals 0. So that means we're crossing the x-axis, okay, when the y's are 0. So now what we're going to do is we're going to simply divide by 2 to both sides, because I know when I divide by 2 to both sides, I get 0 divided by 2 is 0. So now I'm just left with x minus 5 times x plus 2 equals 0. What's going to happen here is what we're going to do is we're going to take x minus 5. We know that we can use the zero product property. Whenever you get two numbers multiply together equals 0, you know one of them has to equal 0. Let's make the first parenthesis group 0. What x value will make this this group 0? What x value will make this parenthesis 0, guys? X equals 5. Let me just sneeze. And then what about the other x value? Okay, x plus 2, we want that to equal 0. Well, I'm going to do opposite operation. And we know that x has to, x equals negative 2 to make that second parenthesis group 0. Therefore, those are your two x-intercepts. X equals 5 and x equals negative 2. Are there any questions? I had a student last period say, Miss Sanchez, well, don't you just take the opposite? Negative 5, what's the opposite of negative 5? Positive 5? I said, yes, pretty much. That's what it is. Some of you might be like, I need to do it algebraically. Write it out. And then do opposite operation. Anybody know what method I can use for 42? What might be a good starting point? Since it's 3 terms. The x method. Good. A times c goes on the top. B goes on the bottom. A times c, that's 6. You got to multiply to 6 and add to negative 5, right? So what are two numbers that multiply to 6 and add to negative 5? Well, let's see. 1 times 6. Oh, that's probably where I should start. And we get a negative number. However, whoa, I don't get a positive 6, so that's probably not a good way to go. What about the next option? 2 times 3, right? They both are negative, and they multiply to a positive 6, and then they add to a negative 5. So that's the way to go. You see how I did my two possibilities? 1 times 6, that could have worked, but it didn't because of the signs. What I'm going to do is now I'm going to go to my box method. My box method looks something like this. I'm going to move this a little bit over here. And what I'm going to have is a nice 4-term polynomial. X squared goes top left, 6 bottom right. We know that this guy right here, this negative 5, gets split up into 2. Into negative 2x and negative 3x. Now you find your GCF of the top row. That's just x. We get x times negative 3, and x times negative 2. We just factored the trinomial. So those 3 terms turn into factors. X minus 2 times x minus 3 equals 0. Again, it's zero product property. Okay, this guy, the first parenthesis group must equal 0, so add 2 to both sides. X equals 2. Next parenthesis group, x minus 3 equals 0. Add 3 to both sides. You get x equals 3. Therefore, your two x-intercepts are x equals 2 and x equals 3. Are there any questions? You might want to pause the video when you get to this problem. Let it simmer. Now number 43. Draw a quadratic with the following number of solutions. So, first of all, I think some of you might need to see the overview. Here you go. Let's zoom out. All right, there you go, right there. 40, 41, 42. Okay, sweet. Draw a quadratic with the following number of solutions. 2 solutions. That means you have to cross this parabola has to cross the x-axis twice Doesn't matter how you draw it as long as you cross it twice. One solution, the parabola only touches the x-axis once. So only one x intercept. And then no solution. Oh, you don't even cross it at all. And there was a student that said, does it have to be the way you draw it? No, look at all these ones. These are also the same. So it doesn't matter where, as long as you touch it once, right? You can do one here in the center. So it's kind of nice that there's multiple graphs that satisfy those solutions. When you're ready, turn the page. Now we're getting to the problems that I think the majority of you need extra help in. So let's focus on 44 in its entirety. And here we go. First of all, it's a 3-term. It's a trinomial, and it's in standard form. So we might want to use x and box. It does say solve the quadratic by factoring, and then graph the x-intercepts, or the solutions. So let's start with our x. I want you to write that down. A times c goes on top and b goes on the bottom. -5 goes on top and 4 goes on the bottom. Two numbers that multiply to -5 and add to 4. Oh, Miss Sanchez, I know 1 times 5 is 5, but I need one of them to be negative. And obviously the smaller number needs to be negative to get 5 minus 1 equals 4. All right, plus and then multiply. Let's make a nice box. Here we go. Uh-oh, there you go. And I am going to then put my x squared top left, -5 bottom right, and you get -x and 5x. Doesn't matter where you put them. You could put the plus, you can put the minus where they belong. Find the GCF, x times x times 5, and -1. So these are your two factors, x minus 1 times x plus 5 equals 0. So the trinomial got transformed. And what you're going to do now is, what x value makes the first parenthesis group 0? X equals 1. The next parenthesis group, x minus 5, we want that add opposite operation. X equals 5. So your two x-intercepts are x equals 1, x equals 5. Okay, and graph them. Okay, I see that, 1 and 5. The axis of symmetry, I notice a lot of you just say, hey, it's in between these two, right? Right, 2 to the right. And then if you go 4 to the right of the x equals 1, you get to the next point. So axis of symmetry does split up the points, right? In a symmetrical manner. So the axis of symmetry is x equals 3. Okay. Some of you might be like, I don't really get that. So use the formula. X equals -b over 2a. -4 over 2 times 1, -4 over 2 is a -2. Oh wait, hold on. Am I doing something wrong?
I think x plus 5 would give you an x equals -5.
Oh, yes. Thank you so much. Right here. I added x plus 5. I wrote down -5. So sorry about that, guys. Let me zoom in. X plus 5 equals 0. There you go. Subtract 5, and you get x equals -5. See? Do you see how axis of symmetry will help you get to where you need to go? And therefore, you can still find the middle number, 1, 2, 3. 1, 2, 3. It's right here. So it's x equals -2. There you go. Very good job. You guys with me? Yeah, so it's important for you to always look at opposite operation. I think that's where I goofed up. I wrote it down wrong. I'm just making sure you guys are awake. Good job. What's the vertex? Well, the vertex is now you plug it in. So y equals -2 squared plus 4 times -2 minus 5. Plug that into your calculator and you get -2 squared plus 4 times -2 minus 5. I got -9. So this is -2, -9. It's all the way down here. All right. What's the y-intercept? We know the y-intercept is always the c value, 0, -5, when all the x's equal 0. There we go. 2 to the right. That means we could go 2 to the left because this is symmetrical. Connect your points. Oh, that was not that great. There you go. There you go. Are there any questions? There you go. Graph the quadratic, and there we have it. Okay, sweet. Let's go over number 45 now. Same idea. I want you to give this a try. Go ahead. And then I'm going to set you up for success. Does say solve by factoring. By factoring x in box. Check your answer with mine. Maybe you want to look at your factors. All right, hopefully you guys got x minus 1, x minus 7 equals 0. Opposite operation, just x equals 1, x equals 7. There you go. Axis of symmetry, you go 1, 2, 3 to the right. 1, 2, 3, there you go. So it's right here. At x equals 4, and you can double check your answer, which is -8 over 2 times 1. 8 over 2, which is equal to 4. Very good job. All right, you could also use that formula if you'd like. I'm putting it in a little cloud. The little cloud just tells you, hey, that's probably something good to put on your flashcard. The vertex, I hope you guys were able to find your y, the corresponding y here. And you guys got 16 minus 32 plus 7. Did you guys get -9? So it's 4, -9 for the vertex. What's the y-intercept? Oh, it's just the c value, 0, 7. And what you did, you went 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right. There you go. Connect your points. It's nice. There you go. Hopefully you guys were able to do 45 on your own. When you're ready, turn the page. we're about to step into simplifying radicals, but there is this one more problem that has the same process: finding the roots by factoring, find the axis of symmetry and the vertex, domain, and range. See if you can give this one a try. I'm gonna set you up for success. It does say factoring. You guys can take a short break soon, but just go ahead and practice this problem. Hopefully you got these as your factors. Okay, hopefully. If you didn't, double check your work. Double check. Multiply, two numbers that multiply to -5 and add to -4, right? It's good to know that's an easy one. Then x minus 5, the first parenthesis group, equals 0, x equals 5. Second parenthesis group equals 0, so subtract 1 to both sides. X equals -1, x equals 5. You gotta find the axis of symmetry somehow. I always count 1, 2, 3, 1, 2, 3. It's x equals 2. But you could also use the formula. And did you guys substitute to find the y? Make sure you do that. Are we good? All right. And we get -9. Did you guys get -9? So we get 2, -9. I'm gonna double check my work because that's the same vertex that we got in the previous problem. It's kind of neat. The y-intercept 0, -5 because all the x's go to 0, so you're just left with the c value, right? When you cross the y-axis, you don't go left or right. And it's symmetrical, boom. So you connect all those points. There you go. There you go. And the domain is, you read it from left to right. Always -infinity to infinity for a parabola. And what's the range? You read it from the bottom, -8, bracket, to the top. And it's pointing forever to the top. I always look at the y value, if that makes more sense. So I always like to label my vertex. This is 2, -9. And then I always look at my y. I kind of put a little cloud over it. Okay. That's it for problem 46. I do want to get all the way through problem 50, and then we'll take a short break. So why don't you take a moment to write a list of the first 15 perfect squares, and then make a list of the first 10 perfect squares. I'm going to put a big cloud over 47 and 48 because I think those are good things to put on your flashcard. Think about square numbers. Oh, you square 1. Oh, you square 2. Oh, you square 3, etc., etc. See if you can write that list down. I would say don't just copy these down. See if you can take 3 times 3, 4 times 4. Can you do that in your head? Or you might want to use a calculator. Don't just copy. I know your brains are like, let's just copy off the screen. No. Continue. You can use a calculator. I sometimes like to use it. I don't have all of these memorized. Sometimes I'm having a long day and I'm like, I really don't know. But I can figure it out by plugging it into my calculator. ... because there's more. The perfect cubes one is you take that number, like the number line, number 1, and cube it. 1 times 1 times 1. 2 times 2 times 2. 3 times 3 times 3, etc. First perfect cube is 1, 8. Ooh, does anybody know what 3 cubed is? 27. 3 to the power of 3. 4 to the power of 3 is 64. 5 to the power of 3, 5 times 5 times 5, 125. 6 to the power of 3, 216. 7 to the power of 3 is 343. So almost there. And then we take 8 cubed, 512. 9 cubed, 729. 10 cubed, and what do we get there? 1,000. And ... I think those are important numbers to put on your flashcard, because when you start simplifying, now we're getting into simplifying radicals, we have to be able to take out a perfect square. So divide out a perfect square. All right, number 49, is that on our list? First of all, I told you guys that when you have a radical, you got to look at the outside of the radical. If there's nothing there, by default, it's a 2. So you're looking at 2 numbers that multiply by itself, it gives you 63. Is that possible? 2 numbers multiplied by itself equals 63. Is that in my list of perfect squares? No. So therefore, I ask myself, what perfect square can I divide out by? Divide 63 by. What perfect square can I divide 63 by? 7's not a perfect square. 7 times 7 is 49. So 49 divides 63?
No.
No. No, 64 is too big. And it doesn't divide it evenly. You got to go down the list. You got to list 1. Does 1 divide it? Yes. Does 4? Does 9? Does 16? 3 is not a part of that list. So you have to only look at the numbers on the 9. Because 9 times... Yeah, so 9 times what? Oh, sorry, 7. And you take the square root of both, right? Because that's a nice property that whenever we have 2 factors, we go ahead and we can split that.
I did that.
So then what's the perfect square of 9? What's
3.
How that simplifies to 3, and then leave your radical 7. And then that's it. That is your final answer, 3 rad 7. We took out a perfect square. I know, right? Now we're looking at perfect cubes, right? Because there's a 3 outside the radical right there. So what's a number multiplied by itself 3 times? That gives you 27.
3.
Because
3 times 3 times 3.
There you go. That one's not bad. 51, 52. I think we can go ahead and do those. Rationalizing, guys, it just means that we don't want the radical down in the denominator. So what we're going to do is multiply both top and bottom by radical 7. It's kind of like when you do multiply by 2 over 2. We know that 2 over 2 is equal to 1, so we're not changing anything. We're just rewriting. So this equals, keep your top the same. Look, the top is 6 times 7. 6 rad 7. Over, and then what's the square root of 7 times the square root of 7? Uh-oh, Miss Sanchez. This
1.
is equal to radical 7 squared. So what happens here? This is equal to just 7. Yeah. So remember, a radical and a square cancel each other out. Let's try one more time. I want to get rid of this radical right here, this radical 6. So what I'm doing to both top and bottom is multiplying by radical 6. It's the same thing as multiplying by 1. Keep the top the same, 5 radical 6. But the bottom, you're going to take these two guys, radical 6 times radical 6, square it. They cancel each other out because they're inverse operations. There you go. So this is just 3 times 6. So this is 5 rad 6 over 18. And box in your answer. We don't need to simplify any further, so we are done. Are there any questions? All right, we will get started with the second part after the break. And you should be able to see my screen soon. Okay, there we go. So, number 53. A bag contains 4 red, so I'm just going to make a little box here. 4 red, 3 blue, 5 green marbles, and 1 ball is selected. Okay. Find the following probabilities. Okay. Probabilities, remember, it's part over whole. And we got to make sure that they're in percentage. So, what's the probability of being red? So, remember, part over whole. What's my whole? What's my total here for balls? 4 plus 3 plus 5. 8 plus 4 is 12. So the whole is 12. And how many are red? 4. Just plug that into your calculator. 4 divided by 12 is equal to 0.33 repeated, but then multiplied by 100. So it pretty much looks like this, repeated, and that's 33.3% approximately. Okay, put a little bar. What's the probability that you're blue? Okay, again, your total is 12, but your blue is 3. 3 out of 12, that is 0.25 as a decimal, but then multiplied by 100. Or move the decimal over twice. 25%. Probability that you're yellow. I don't see any yellow. I only have red, blue, green, so 0%. What about if you're blue, if you're red or green? Okay, so you got a probability that you're red or probability that you're green, right? So probability that you're red is 4 out of 12 plus green, which is 5 out of 12. And what is that? 9 out of 12, which is 0.75. Move the decimal over, that's 75% of the marbles that are that are red or green. Are there any questions? Okay, let's go to number 54. A 6-sided die is rolled. Find the probabilities of each roll to the nearest percentage. Okay, so here we go. We do have 6 die. We have a 6-sided die. So we have 1, we have a 2, 3, and then I'm just going to write numbers. 4, a 5, and a 6. 1, 2, 3, 4, 5, 6. Total, or the whole, because we're still finding part over whole, is how many faces do we have? How many different numbers? 6. What's the chance, the probability of you rolling a 5? 1 out of 6. 1 out of 6 is 0.1666 repeated. Multiplied by 100, it's 16.6% approximately with the 6 repeating. And now, what's the probability that you're an odd number? Well, how many of these are odd numbers? 1, 2, 3 out of 6.
50.
Yeah, which is 50%. What about that you're greater than 2? You're not equal to 2, but greater than 2. How many faces are those?
4.
Oh, greater than 2. 1, 2, 3, 4. 4 out of the total of 6. That is equal to, again, 0.666 repeated, which is equal to 66. Oh, actually, this one's a little higher. 66.6 repeated. Oh, sorry. I'm going to move my image that way. Repeated. There you go. Any questions? Now, what's the probability that you have a 2, that you get a 2 or an even number? Okay, get a 2. That's just one of them. Or an even number, you get, okay, here's a 4 and here's a 6. So again, it's 3 out of 6, which is equal to 50%. Are there any questions on what I did? Don't forget to start with your total. And I always like to draw my faces, like what are my outcomes, right? A 1, a 2, a 3, a 4, 5, or 6. Okay? Always draw it out. Put them in a little box. I mean, I always like to put it in a big box. Now let's do number 55. I think these are my favorite. We're skipping E and F. Below is a two-way frequency table which shows the data collected on the preferences of 50 students and the foreign language class they are registered for. Find the following probabilities and round your answers to the nearest percentage. I need to find totals, but hey, you know what the good thing is? They already put down totals for the rows, right? For the rows, and they put down the total for the columns. Look at that, which is nice. And then they put the overall total at the very end, 50 students. Okay, this is what we're going to do now, okay? We're going to take a look at 9th grade. Okay, how many students are 9th grade? It's in yellow. You look at that row. It's 20 out of 50. Shh. 20 out of 50, and plug it in your calculator, is 0.4, and turn it into a percent. That is 40%. How many prefer German? Look at the column of German. That's 11 out of the total, which is 50. What's 11 out of 50? Well, that's 0.22. Round your answer. Go ahead and multiply by 100 and get 22%. How many are 10th graders and prefer French? So go ahead and use your 2 pointer fingers. Go to the 10th grade row and then go to the French column, and that's 12 out of 50. And that is 0.24, which is 24%. Again, get your pointer fingers, 9th grade row, and prefer German. That is 8 out of 50. 8 out of 50 is 0.16, which is equal to 16%. Are there any questions? I'm going to leave the or just because I didn't teach you guys the formula for or, and it gets a little tricky with the ors. All right, turn the page. We're almost there. We got until number, what's the last question, 64? I think so. These ones are good. We've seen them before. We've seen them on the study guide. So JP Morgan employs 20 workers whose ages are below. Construct a dot plot using the given data. So go ahead and construct a dot plot. It's going to take you a little bit of a while. So I'd rather just answer the questions. How many workers? Remember, dot plot is like, for example, I'm going to go with 44. Or sorry, let's go with 32. I only see 132, so I'm going to put 1 dot. That's it, right? Okay, cool. So let's just count. Let's just find the probabilities here. How many workers are 59 years old? Count, okay, are 59 years old. I only have 1, 2, 3, 4. Let me double check. I only have 4 workers that are 59 years old. Write that down. What percentage of the employees are older than 50? Okay, hold on. So I know there's a total of 20 workers, so add a 20, but how many of them are older than 50? Cross it out. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did you guys get 11? Did I miss one? 11 out of 20, and that's 0.55 as a percent multiplied by 100, 55%. What percentage of the employees are younger than 40? And make sure this is also out of 20. Younger than 40. Here we go. 1, 2, 3, 3. Yeah, 3. 3 out of 20, and that's 0.15, which is 15%, just by moving the decimal to the right 2 times. Let's look at this next one. All employees younger than 58 are called associates. How many associates are there? Younger than 58. Let's look here. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. It's just asking for the associates, so 14. Okay. Write this down. Now let's do 57. The first thing I want you to do is go ahead and looking at this this histogram, go ahead and see how many students waited, or the number of users that waited. So that's 1, and that's a 4. So sorry that you couldn't really see it. That's 15. Can you guys read? This one's going to be 11, and this one's going to be 3. Yeah, so this is 1, this is 4, 15, 11, and 3. It's going to be easier to read when you have the exam, okay? Right now I know it's a little bit, the y-axis is not as pretty to look at, right? How many people registered? Can we add those up, guys? 1 plus 4 plus 15 plus 11 plus 3. You plug it into your calculator, 34 people. What waiting time was most common, guys? 60 to 64. And what was the least common? Yeah, and I'm going to put a comma. The least common was 50 to 54. What time range did 51 people have to wait? Sorry, what time range did 5 people have to wait? 0. What if a wait time of more than 60 minutes is only if you had a problem while registering, how many people have a problem while registering? What do you guys think? More than 60 minutes? Okay, more than 60 minutes. You got to look over here. 60 to 64. You look here. What's 15 plus 11 plus 3? 29 people. Very good job. When you're ready, go ahead and turn the page. These are going to be nice and easy. So 58, it says draw a histogram that is left skewed. Remember, something that is left skewed, that means the tail is going which direction? Left. So just draw a little tail like that. That's usually what I like to do. And then draw little boxes, right? You can kind of, it doesn't have to be, and it's a histogram, so they have to be connected. These boxes are going to be connected. It doesn't have to be accurate, but just getting the point across, right? Left skewed. Something that's right skewed, if you want to do something like that, right? Right skewed. Same thing. These are all connected. There you go. Yeah, so you know that the tail points to the right if you're right skewed. And this is left skewed. I think the question was asking for, and then draw a histogram that is symmetric. So, hey, I'll erase my right skewed just because that was just extra. I hope you guys can think about that too. But now a symmetrical one, it looks like this. Everything kind of falls in the center like that. Everything's kind of like symmetrical. Mirror reflection, if you draw a line down the middle, it's pretty symmetrical. Left side equal to the right side. Now let's find the mean, median, and mode of the quiz values. So what's the median? And first of all, let's write these in order from least to greatest. The smallest number is 13. Then we get a 70, and then a 71, 77, 77, and 82. Median is the middle number. Cross out first, last, first, last. Wait a minute. We have two middle numbers. How are we going to find the middle number of 71 and 77? It's 74, and the reason it is because you take 71 plus 77 and divide by 2, and that gives you the middle number. Now, what is the mean of the data? The mean is you're going to have to take all these numbers and what? Yes, add them all together and divide by?
6.
Yeah, there's 3, 4, 5, 6 numbers. So divide by 6. See if you can plug that into your calculator. Ooh, it's a nice whole number. Did you guys get a nice whole number? Think this problem you were supposed to do outside? Did you guys get 65? Good. What's the range? 82 minus 13. Largest minus smallest. Did you guys get 69? Are there any outliers?
13.
13. It's very far away than everybody else. Is this skewed left or right?
Left.
Left. Because of that outlier. Right? The smaller you are, the more you are to the left. The larger you are, if there's an outlier to the right, it's going to be skewed to the right. Very good job. Now let's go ahead and do number 60. It says identify the minimum value, the lower quartile, the median, the upper quartile, and maximum value. It's a good thing that these are all in order. I'm just double checking that they are. And the minimum is the first number, and the last number is the maximum. Find the middle number. Go ahead and use your folding technique, I like to call it, because if you were to put these numbers in a string, you could just fold them, and you'll see that you have two middle numbers. Find the middle numbers of those, and you get 68. So 68 is the median. Find the middle number of the low. So 66 belongs to the lower part. And you get two numbers, 47 and 54 in the lower part. And you get 50.5 for Q1. And then you get, same thing, cross out, 74 and 81. Divide by 2, and you get 77.5 for Q3. All right, so this one's just like half, like you're finding the half of the long list, and then you look at the lower list and find the half of the lower list, and then find the half of the upper list, and you're done. So the minimum is just the number 41. Quartile 1 is 50.5. Quartile 2, which is the median, is 68. Quartile 3 is 77.5, and maximum is 90. Are there any questions? All right, now it says construct a box and whisker plot. So I'm going to save some time, and I'm just going to put 41 here. And I know that I'm going to put 50 here. Put 60 here, just to save some time. 70 and 90. Okay, there you go. And I'm going to call this 40. And I'll put this here, right? 68 is somewhere here. and connect there, and then 77.5. There you go. Oh, 68 is, let me erase this. 68 is about here, and then the last one, 77.5, right here. Okay, perfect. It doesn't have to be, I'm doing this really quickly, guys. It's just a quick sketch. But when you do it, it has to be pretty accurate. And on, since it is going to be multiple choice, just make sure you read the number line, okay? Make sure you're not jumping by 2s, by 3s, by 7s, if you don't need to jump by 3s or 7s. Turn the page. All right, so we have 1, 2, 3, okay, 4, 5, 6 problems to go. Why don't we tackle them? I know that we have about 10 minutes. We can do this, okay? Let's do it. Shh. Okay, let's get it done. Use the box and whisker plot below to use the box and whisker plot below to examine the scores students received on the algebra test. Again, that's your mid is at 20. You might as well start labeling. There you go. Your range is Q3, which is 75. Largest, oh my goodness. I'm just reading this. I might as well label this to not make any mistakes. There you go. So let's do largest minus smallest. So max minus min is 95. Minus 20 is 75. The median is Q2, which is 40. Quartile 3 is at 75. Quartile 1 is at 25. Inner quartile range is Q3 minus Q1, which is Q3 is 75 minus 25, which is equal to 50. What percentage of the students earned a score of 25 or higher? 25 or higher is all of this section. That's 3 sections, 3/4, 75%. What percentage of the students earned a score between 40 and 75? So between 40 and 75 is right here. It's just one section, one part, 25%. Now let's look at 62, the explanatory versus the response. Here, I asked you to look at both scenarios, house size and price of the house. So house size varies, it's explanatory, whereas the price of the house depends on the size. Interpret the slope of the line in terms of the context. Slope is 150, so over 1. So it looks like the price goes up by 150 for each, I don't know, house size unit, right? House size. And then we don't know what units we're talking about. Could be square feet, most likely, right? Per square feet. But I'm just going to put, because we don't know, just house size unit. Interpret the y-intercept. It's just $50,000. So the house, the price of the house without, or the process, the initial, I think that's the best way. The initial price of the house is at $50,000. But you have to consider, so that's like your starting price. But obviously once you consider square feet, that's, it's an added amount. Would the correlation of R be positive or negative, guys? If you increase the house size, you increase the price? Positive. Increase, 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 increase. That means this guy goes up, this guy goes up, boom. Okay. Let's go ahead and do number 63. Advertising spending and sales revenue. So advertising. How much you spend on advertising, and then the sales revenue, like what you make out of it. Positive or negative, guys? Well, if you had more ads, then you get more sales. That's positive. interpret the slope. It looks like for the revenue increases by 2.5 each time you spend on an ad. Okay, so the revenue increases by 2.5 each time you spend on an ad. Predict the sales revenue of a company that pays $1,500 for YouTube advertisements. So revenue, so now that we have an equation, we can say that pays this much for ads. So X is ads, so we're gonna go ahead and do that. Do the math. Replace the X with that number. Plug it in your calculator, super easy. Super easy. 2.5 times 1,500 plus 1, 2, 3, 4 by 10,000. And then you get 13,750. There you go. That's how much you make in revenue. Turn the page when you're ready. Oh yeah, can I finish this? Yes, I can. Let's start with the easy ones at the bottom, 66. A lot of you did this outside. It's linear, it's exponential, and it's quadratic. I apologize for not capitalizing the E in exponential and the L in linear. There you go. Now we have this one. Take a look at the table. If it's mx plus b, if it's mx, go sit down. If it's mx plus b, it's linear. And if it has a squared trinomial, right, quadratic. And whenever we have exponent x, it's exponential. All right, hopefully you guys got all those down. Now look at 64. When you have a positive strong R value, all your dots, I would suggest drawing a line first. Then put the dots really close to, like since it's strong, all the dots are really close to the line. And negative, that's going to be a negative line, and not the dots are not going to be close at all. You're right, 0.03. So you're going to have one here, 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 here. Whereas this is negative 0.85. It's close to negative 1, so it's a little bit stronger. Okay, just a little bit, not that much. Are there any questions?
Easy.
It's too easy. Great. Go ahead and pack up. And don't forget to look at this. I'll be posting the PDF of this as well.